I am realizing I probably should have had you graph them yesterday, but well, if you ended up with something like this, if you ended up with x less than 2, on the number line, what would you do? You would go to this number and make a circle. Do we color in the circle or not color it in? Why not, Caleb Proft?
Because that means it's equal to.
Right. If it's got an equal to, then you would color it in. This one does not have an equal to, so we don't color it in. And this says we want x's that are less than 2. Where do I find x's that are less than 2? Which way? To the left. Correct. So if I wanted x greater than or equal to -3, greater than or equal to, I would go to -3, color in or not? Color in. And then which way are the greater than? To the right, to the right, to the right. So that's not that big of a deal. The one thing I always tell my Algebra 1, the Part 1 kids is sometimes they have a hard time, and so do I actually. Okay, which ones were greater than -3 again? Which values are less than? -5 is less than -3. Sometimes okay. But if you have your variable on the left side, then the inequality sign points in the direction you're supposed to color. Only if the variable's on the left side, then it points the direction you have to color. See that? That's a little shortcut. You don't have to think. Well, today it says on page 65, we are going to be doing combined inequalities. Combined inequalities. So, plus 5. X less than or equal to 10.
What page did you say?
I said page 65. 65. Rodmar, is it okay? Can you see now? Is it focused? You know what? I shouldn't be using red though. Red seems a little bit harder to see. So when we're looking for combined inequalities, what we're looking for are values of x that will solve both. I want x's that will work here and here, both. Well, guess what? It's kind of like a 2-for-1 problem for me. You solve the first inequality. You know how to solve this, right? That's what we did yesterday. What would you do first? Subtract 5. 2x greater than, divide by 2, divide by 2. X is greater than, and I don't need to flip it because I divided by +2, right? But remember what I said over here? If the variable is on the left side, I don't like my variable over there. I want to take this whole thing and flip it over. Now, I'm not flipping the inequality though. Do you see the big part is by the x? I'm going to leave the big part by the x. I'm just taking that whole thing and flipping the whole thing. So both of those mean the same thing. If I asked you to graph that, what would you get if you graphed that? You'd go to -1. You'd go to -1. Color in or not color in? Not color in. And then which way would you go? Right or left? Which way are they greater than? Good, yes, to the right. Those are the values that are greater than. So any value that we pick in this area right here, if you plugged it back into this original, it would work. It would work. Like, let's say we pick 0. 2 times 0 is 0. 0 plus 5 is 5. Is 3 greater than, or is 3 less than 5? Yes, so it works. Now we have to solve this one. Same thing again, solve it and get x. Divide by 2, divide by 2, and I get x less than or equal to 5. Graph that one. Where is x less than or equal to 5? Go to 5, color it in or not? Color it in this time. And which way are the values less than 5? To the left, to the left. Right? So from here down, any value that I pick will work in this equation, inequality. Now, up to this point, it's just like we did yesterday. Today, we want a value of x that solves both of those. Where would you find the values of x that solve both? Where would you find the values of x that solve both? Where?
Is it the 7 to 7?
It's where they overlap. Yes. It's where they overlap. Hi, Caitlin.
Hey,
How are you?
good. A little bit.
Oh, look who's in here.
Hey, Brookie. I remember first hour.
You do?
Yeah, I'm a TA. She got mad at me.
There's a camera right there, so get out of the way. Nice one, Caitlin.
She got mad at me this morning.
Solid.
I forgot about that.
Me too.
Oh, well, it's supposed to be just like they're here, right?
True.
Yeah.
It's just the kids I'm standing in front of instead.
Thanks for the staple.
Anytime, anytime. Nice to see
Good to
you.
see you too.
I like your hair.
Thank you.
Short and sassy, just like you.
Oh, yeah. Brooklyn's just about to die right now.
Yes, she is.
Interesting.
Yep, have a good day. So Madison says, where do you find numbers that will solve both? Where they overlap. All the red ones solve this. All the green ones solve this. And the numbers that solve both are where they overlap. So that's why I didn't draw it on my good number line, because I'm going to put it down here. Where do they overlap? Starting at -1 and going up to and including 5, because 5 is colored in. So really what we're looking for today is where they overlap. You do one like yesterday, you do another one like yesterday, where they overlap. But wait. Sometimes, here's where it starts to get a little iffy. 7 minus 2y less than or equal to 1. Or, notice this time it's an or. 3y plus 10. You guys are making sure I copy this right, aren't you? Is less than 4 minus y. Hey, one other thing over here. One other thing. Let's say, here's my graph. Doesn't matter what those numbers are. But let's say I graph the first one and it goes this way. Remember, what am I looking for? With an and, you're looking for where they overlap. So in between. But I have another problem here, a separate problem. I graph it, it goes this way. I graph it, and it goes this way. Then what happens? Are there going to be any values that would solve both the equations? And that's what we're really looking for, are values that solve both equations. What are we going to write if there are no values that solve both? If they don't overlap, there are no solutions. If by chance they don't overlap, there are no solutions. Does that make sense? Okay, so then to my or over here. Or is a little bit less strict. Instead of wanting numbers that solve this equation and this equation, I want a number that will solve this one or this one. 7 minus 2y less than or equal to, how about 1? Helps if you put the whole thing in there. I need a number that will solve either this thing or what is this? What is this? Okay, I guess we're okay. This is a whole one. So do I have two inequalities? There's one here and one here. I guess I'm okay. I think I need to go home. Lack of oxygen. So, solve the first one. Just like normal. What would you do to solve this? Yes. Subtract 7, subtract 7. Over here you'd have negative 2y. What do you have here? Then what? Divide by negative 2. Divide by negative 2. So I get y less than, oh, good job, good job. We divided by negative 2. So we have to flip and make it greater than. Right? So, number. Think that's enough? So, go to 3. Should I color it in or not? It's equal to, if it's equal to, you color it in under there. Oops. So right here. And which way will my line go? Which way are the values greater than? To the right, to the right. Then I'm going to solve this one. First, I have to get all the y's together, don't I? I have y's here. How about if I add 1? Is that going to be 4y? Then what? Minus 10 minus 10. And so I get 4y negative 6. Oh, jeez. Okay, time to go home. Pack her up. Divide by 4, divide by 4. Y less than negative 6 fourths, which is negative 3 halves. which is 1.5. So y less than negative 1.5. Negative 1.5. Negative, isn't negative 1.5 between -1 and -2? So we can guesstimate negative 1.5 would be in here somewhere. Make a big circle. And should I color it in or no color? No color, because it's just less than. Which way does my line go? To the left, to the left. I want the values that are less than. Now, here's an example. If this one were an and, with and, they have to overlap. They have to solve both at the same time. This one solves that equation. This one solves this. If this were an and, it would be no solution. There are no values that solve both. But with or, it only needs to solve this one or that one. It only has to solve one of them. So over here, you see these? These values solve one of them. One or more, at least one. And so do these values solve at least one. Right? So that's going to be your answer. This filled-in number line will be your final answer. Does that make sense? Does that make sense? Do you have any questions so far? I just have one more little thing to show you. It's this. Did I ask if you had questions? All right, maybe I need to go to bed earlier. Less than 2x plus 5, less than 2x plus 5, less than or equal to 15. This is one more kind of problem that you're going to run into. Look at it. It doesn't have an and or an or. Now what? No and, no or. Well, here's two. There are two inequalities there. Here's one of them. You cover up the last inequality and everything that goes that way. So there's one inequality. Write that down. Then guess what you're going to do? Cover up the other inequality and everything that goes the other way. So this thing, do you see where we get the two inequalities then? Do you see? You're still embarrassed. It's okay, it's just us. That's the good thing about a small group. So I have the two inequalities. The only thing that's missing is the and or the or. Guess what? When it's written all as one like this with the two inequalities in there, it's always, it's always an and. It's always an and. So what would you do? You would minus 5, and you would get 2x. This actually happens to be the one I did down there. Divide by 2, you get x greater than -1. You can graph that one. Here, same thing, minus 5. I just disguised it a little bit. Divide by 2, so x less than And we did that. Over here, x less than or equal to 5, we colored in, and we went this way. The other one was x greater than -1, that's here, going that way. And because it's an and, you want to know where do they overlap. You've got where they overlap, right? Simple Simon? Not bad, right? So every one of the problems we do today is like doing 2 of yesterday. Every one of the problems today is like doing 2 from yesterday. Every one of the problems today is like doing 2 from yesterday. Anybody with questions? Are there any questions? Does anyone have a question? Does anyone have a question? So I am on page, would that be 67 and 68, I believe. Can you see this, Radha? 67, 68. What?
I'm listening to you, but I can't see it.
Okay. 67, 68, written exercises 1 to 15. 15, not 50, 15. Okay? Are we good? Are we good? Here are these people. All right.
This way?
Yes.